All right, welcome to this presentation. I'm going to go over some problems related to ridge regression in this video. These relate to what you might encounter in homework set 8. So I've got a data set here. You can see I've already got the head there, so I can see the first few observations for y and then x1 through x4, but I could just get a summary out here too. Do that. And I can take a look at them. I can get scatter plots, histograms, box plots, and so on, but I'm just going to move more quickly through this. So I just want to run a regression, nothing unusual here. And I've got data, it's going to be H08, and I just run through that. And maybe I actually wanted to say summary to have this look a little more familiar. So with what I just typed, it gives me the model, right? These are the coefficients, but maybe I want to look at a little more. So I type summary there, and now I get what is R square. It's very small. I can see the same coefficients here, but I can also now see the p-values. It looks like the one that's closest to being statistically significant is x3 in this little data set. Okay, so now to standardize the data and run a no-intercept regression, I'm going to make a new data set here then. I'm going to call this Z H08, because these are going to be Z values. And I'm going to take an approach here that's going to give me an error first. I'm going to say scale H08. So I'm going to just do that. And then maybe I want to see those observations. So actually Z H08. So I can do that. And it looks like I've got everything going just fine there. And then here I'm going to have a model. So we'll just call it M. Maybe we can call it MZ since we've got the Z's in there. And just do this. Y rest on everything. Data equals ZH08. And let's just see what happens if this runs. And it tells me down here, I've got some problem. All right. What is going on here? Well, it's one of the things it says is data must be a data frame, not a matrix or an array. So that might suggest to me that perhaps this data, this ZH08, is being stored as a matrix. So what's a solution to that? I can do as dot data frame to make this a data frame, because it says here data must be a data frame. So let's try that. Again, do head. Looks the same, right? So it appears to you, or to me, at least to me, I don't know about you, looks the same, but R is seeing it differently. So just keep that in mind. And so then I want this standardized data and a no-intercept regression. Well, I'm going to do this twice here because I've got this. I don't have it in a no-intercept form here, but let's just look at this together for a moment. And then I want summary of this. And we're going to see that there is an intercept in this version. Right, so you'll see a few things. You'll see that there is an intercept, but it is very small, right? So E-16, so that means 0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000007, right? So that was kind of silly. And maybe you're annoyed that I did that, but it's zero essentially, right? But how can we get something more precise or better here? We just enter in -1 here. That removes the intercept altogether. So let me rerun this. And now you'll notice there's no intercept down here. A few things though to note: the R square is the same as our original model with the original data. And so are these p-values and t-statistics. So for example, negative 0.383, negative 0.38. Okay, so slightly different, that rounded there at the end, but they're basically the same. Right, there's the same information, right? So let's just look at another one, 1.598. Where was I? Yeah, 1.5. I mean, they're very similar. Okay, is a point to get at, and the R square is the same, 0.06239. 0.06239, right? So you've standardized the variables, but it hasn't really changed the information that's being provided by those variables. Right? So now, though we would just interpret these coefficients differently, right? This means as the variable x1 goes up by 1, meaning it's more than one standard deviation away from its mean, then the y variable would increase by 0.01669 standard deviations, if you will. Okay, so that's just a little bit there. Got that standardized regression. So now we're focused on ridge regressions. So we're looking at this here. Use LM ridge in the mass library. So that's the focus here, is to use that procedure. So let's go ahead and give that a try. Let's go ahead and do this MZR. So we're going to do a ridge regression, and let's just try LM ridge. Now I already have the mass library going, but just we can make sure we've got it in there. I've already done that before, but so anyway, we've got that. And so now what we want, we've got this LM ridge, and we're going to put our model in. So y, we'll use all of the variables. We're going to do a no intercept regression, so -1. And we're going to use the standardized data. So data equals z, h08 is what we've got going on there. And then we're going to use for this a value of lambda. We'll just actually, at this moment, it's not particularly important what we choose. So let's just go with something like 0 to 1 by 0.1. It's just a placeholder for the moment. Let's run this. And then we want to maybe take a look at this. So we'll just say summary MZR. So we could do that. And it just gives us some information there. We could, well, yeah, we could do MZR, but this isn't going to provide a lot of meaning to us at the moment, because it's got for each of these values of lambda, and it gives us a bunch of things. So not super meaningful at the moment. But what we want to do is get this HKB estimate for lambda. So the way that we're going to do that is we'll just say MZR, and then let's do KHKB and get something out. And down here, it gives us 34.88. Maybe seems kind of large relative to maybe what you saw in the lecture, but it gives 34.88. So now this says find the Lawless and Wang estimate for lambda. So that's another thing you might want to do. So there, you're just going to just copying and pasting here. And instead of HKB, I'm going to go with LW, and it's going to give a different estimate for lambda. And there it's 32.67. Okay. All right, so those are two different values I can get. So now the next part E, let's say, is use the no intercept model, which we've done before. Use the linear ridge in the ridge library. So let's go ahead and just make sure we've got that in here. Got that. And then I'm going to make another model, MZR. This one I'll call it version 2. So 2 there. And it says use the linear ridge function. So I've got that going on there. And then, yeah, it tells me something about I want the no intercept model. So I'm going to again go with the y and all the explanatory variables, no intercept. I'm going to have my data set, z h08. And then it tells me a few things, right? So what does it say? It says use the scaling equal to correlation form. So scaling equal to correlation form. And then I need a value for lambda. And I can choose whatever I want here. But in the homework, maybe it suggests using the Horrell-Kennard-Baldwin version or the Lawless and Wang, whatever. So we could go with just copying and pasting one of these two values in there, however we saw fit. But you just need some value. So I'm going to go with 30. That's not exactly either of these two, but you could just copy and paste these if you're trying to get these out. So I've got that in there. And yeah, so now I can go ahead and give that a go. Well, so now if I want to look at this, I can do different things, but maybe I just want to see what the coefficients are. So it says, maybe I want to find the coefficients. So I'll go ahead and go with MZR2, and I want the coefficients, so COEF, and go ahead and run that. Oops, I need a Z in here instead of an X. And there we go. And I get those coefficients. I could also do something like maybe I just want to see something else here. So maybe I want to go ahead and go with summary MZR.2. And I just want to see a little bit more here perhaps. And I can get this out. And what I'm going to be going with actually are, I'm going to go with these values here if I'm looking for the coefficients here. So what I've got here instead of in this version up above, right? I want what I'm seeing here as the values. Okay, so there I've got that. So maybe this is the one to use here actually instead of this, but check that out. Then the next part says construct a ridge trace. So again, looking across different homework problems, you may see different things, and it indicates to copy some code from Canvas. So constructing the ridge trace involves some plots. There's a bit going on, and typing that all out from scratch is going to be a bit of work. So let me just suggest copying and pasting, and I am going to grab that out. So let me just copy and paste this from Canvas. So I go over to Canvas, I grab that out, and I'm just going to Control V, and a bunch of stuff goes in there. It might be difficult to read, but I'm going to look at this. So what do I see? I need a sequence for lambda values is the first piece that where I started to copy this out. Ridge trace, so maybe if you're doing Control F and looking in that code in Canvas, you can go for ridge trace. So it's going to go from 0. I'm going to go ahead and say something large here. If it stopped at 32 and so on were the estimates that it gave. So maybe I want this to be fairly large here so I can look at it. And then maybe I don't want this to be quite so granular. Maybe this can be 1 or maybe 0.1. but maybe not 0.01. Then it says ridge trace, and I've got this linear ridge. I don't want this, right? Import, DOPROD, these things don't make any sense in this case, right? What I want here is I've got to change the names of the variables. So I want Y, and I'm going to use all of the explanatory variables. So I'll just use a dot there. My data set is different, right? So it's no longer this st.dfe59. That was an example in class. So ZH08, use that there. And then the rest of this looks good. So I can go ahead and run this part. And now I've got this thing ridge trace here. So now I'm going to get this RT1. It just says, so in the code, it said produce the plot of the traces, get estimated coefficients, divide by the scales. So that's just, again, estimating the actual coefficients that you're getting out here, right? So performing something on there, maybe you can just see the coefficients and the scales to give you back the coefficients that you're wanting unscaled, if you will. So let's just run that. Got that going on. And then what's going to happen here in this RT2 is it's going to have those coefficients from RT1 that we just got up above, and it's going to add in this LKSEQ. That's this sequence of values for lambda of 0, then 0.1, then 0.2, 0.3, and so on. It's going to combine those together, right? So that this is going to become essentially our X value, if you will. All right. So got that going on. Then I just make sure I've got one plot out there. So now I've got this line here, and it's got old stuff in it, right? This part here, RT2 LKSEQ. LKSEQ now is like the X for the plot. But what's the Y? DOPROD. That doesn't make sense anymore, right? So I want to change that to X1. And I'm just going to run this and look over here on the far right. And looks a little unusual, perhaps just looks like a flat line down there at 0. So, but that's where I'm looking. And then I want to do this for this next line, but I don't want stock. I want maybe X2. Oops, X2. And it just, if maybe you noticed over here on the right, it put a little line on top, dashed line. And then maybe I want X3. And I just put a little line on top, hard to see. Well, in this case, I have 4 variables, X, so I also want X4, so I'm just going to copy this down here. And I'm going to come back in where it says X3 and X4. I'm going to put that on top now. So, okay. And so now maybe I'm noticing that all of these are down here very low, but for some reason I've got this out here extending up to 50. Why is that? Well, I'm going to go back and show you where this is in the code. This plot function takes an X variable that's there and a Y variable. In this case, that's the coefficient on X1. This type, I'll just make it a line. And then there's a limit for Y, right? The Y axis. So the minimum is going to be the smallest value in this RT2 that we're drawing from, and the maximum is going to be the maximum value of RT2, which was 50, because that lambda, we had it go out to 50 up here because of what this ridge trace was showing. Well, maybe I don't want that to be 50 now, so maybe I want to try something much smaller. Just eyeballing this, I can guess it probably looks like less than 5, but we'll just give it a go with 5 and see what that does. So now I'm just going to rerun these lines, now with the y-axis limit being 5 instead of 50. And that still looks way too big, so maybe less than 1, maybe even 0.5. So let's just go with 0.5 and see if that makes it just appear a little bit better. So actually, let me run these one at a time now. So this is for X1. Then this red line that just appeared on top is for x2. And then this one that appears now is x3. And then this one here is x4. Okay, and I can even get a little more precise on that. Maybe I want to cut this down to x3, and maybe I want to rerun these all again, perhaps. Let's just try that. Right, and you can see how the ridge trace is. Right, there's the suggestions then from the Horrell, Kennard, Baldwin, and the Lawless and Wang. They're a little over 30 out here, but maybe you, in eyeballing this, think that they appear to have gotten relatively stable, maybe somewhere much less than 20, perhaps, depending on how you're viewing that, looking at that. But that would be an example of using these ridge traces. So it's just one other little thing to note here in this code. If you've got this, if you ran these all simultaneously, it just all is going to appear here and be hard to tell that the black line appeared first, the red line appeared second, and so that's x2, and then this one x3, and so on. So you might want to label them with beta 1, beta 2, beta 3, and then that was, if I want beta 4, I need to actually add that in here. So I need to increase this. So what do I need to change in this line? Where this is beta 3, I want it to be beta 4, so I got to change that. Where this is 4, I change that to 5. These things may not be obvious. It just takes a little work with working with plots, but not critical for the homework. As long as you can just get the plot out to eyeball, you'll be doing just fine. And so then I get that out, and there you are. So hopefully that helps just in terms of walking through another example with ridge regression and building the ridge trace. And hopefully that just makes things a little bit smoother with an additional example.